Test 1 2, check, check, 1 2.
So welcome and thanks for joining. We'll be talking about upstreaming Fedora CoreOS. So my name is Clément Vernat. I'm one of the engineering managers working with the CoreOS team. And today we'll talk about this with Ellen.
So hi, I'm Ellen. I'm a product owner on the CoreOS team as well. So yeah, we'll get started. So we're going to talk a little bit about what is Fedora CoreOS, how we're making it and testing it right now, and future plans with where we're going with it. So what is Fedora CoreOS? So we're now an official Fedora edition. So we became an official Fedora edition in Fedora 37, together with Workstation, IoT, Cloud, and Server. So this means we're more integrated with the Fedora release process, including release blocker and go-no-go processes. So we focus on single node clusters in use cases. We're a successor of two container-first OSs, which was CoreOS in Container Linux and Fedora Atomic Host. So we've incorporated ideas from both provisioning, stack, and cloud native expertise, and Fedora Foundation and Upstack SE Linux. So the philosophy of CoreOS comes from the merge between Container Linux and Atomic Host. So the idea was to take the best of each project, which resulted in the following key values. So the first of which was automatic updates. So this was something that only Fedora CoreOS does in Fedora. The idea is for FCOS users to not have to worry about the OS. Automated provisioning, so it makes it easier to have 1 or 1,000 nodes that are the same. And then immutable infrastructure, which leverages the OS tree technology to make it easier for the update nodes. So our release model is different compared to other Fedora variants. So instead of major releases every 6 months, FCOS releases every 2 weeks on 3 different systems. This differs from other Fedora editions. The model is linked to the automatic updates. So in order for users to use automatic updates, this has to be stable in order to not put pressure on the system. And this allows testing in advance of the stable stream to avoid issues. So we are supported on many platforms, and a few of those are now integrated into our automated testing. So some of those are cloud or vert platforms, and some of those are bare metal options. So some of the automatic testing happens during our release process on x86 or AOR64. We also have builds on S390X, but we don't have automated testing on those yet. So it's just some of the statistics on some of the nodes. So the red line you're seeing there is the transcendent line, and the blue is the static line. So the transcendent are including systems that have been live for less than 1 week. The static is systems that have been live for more than a week. The dip in the graph you're seeing there was due to an infrastructure issue that we had. The number of CoreOS instances are coming up and continuing to grow. So we're reaching over 40,000 instances, out of which 30,000 of those are up for more than 1 week. So just some statistics on Fedora releases. So you can see the success of the automated updates. Majority of the SCOF instances are running on the latest version of Fedora. So why can we see older versions of Fedora? So the OKD, so the community version of OpenShift is using FCOS. Updates are managed by the OKD admin, and a specific version of OKD is tied to a major version of Fedora. And for the architecture, some of these are very popular on x86 and AOR64. FCOS is the most popular Fedora variant on AOR64 at the moment. Okay, so I'll hand you over to Clément.
Thanks. Yeah, so wanted to take a deep dive a little bit into how the Fedora CoreOS is released and the release engineering. Since we don't have like the same release model as other Fedora variants, we have a bit of a different process. So yeah, how does a package update lands in Fedora? So you'll see the beginning is very traditional. It all starts with a commit in dist-git where the packager will update their software, Koji build, body update, and it reaches the stable repos of Fedora. Then that's where the Fedora CoreOS magic sauce happens. In Fedora CoreOS, we have like this concept of log files. Talk a bit more about it. Then we do our Fedora CoreOS build, Fedora CoreOS test, and then release. Let's look at this in a bit more visual way. So commit in dist-git, like I just took the example of OpenSSL. Packager will do this work. Build it in Koji, then push the update in body. As you can see, the update reached the stable repo, so now it's available for every users in Fedora. The thing is that up to this point, this update has never seen a Fedora CoreOS system. Like, we went through a lot of testing. People have been providing feedback on body, but this has not been seen by Fedora CoreOS. Yeah, so that's a big point we want to try to work on, is that really the Fedora CoreOS release cycle comes quite late in the packager process. So to get this stability for Fedora CoreOS and to try to keep like user-to-use automated updates, we have like this system of log files. When we're going to, for each release of Fedora CoreOS, we're just going to fix the package versions. So for example, if we go back to the OpenSSL, we're going to say that in the next stable stream of Fedora CoreOS, we're going to ship with OpenSSL 3.084. And that's going to be the fixed version for 2 weeks. And then 2 weeks later, when you get a new automated update, you're going to get a new version. So that's really how it's done. Everything is stored in a Git repository on GitHub, so you can have a look at that, and you can really have like all the versions of all the packages that are provided in Fedora CoreOS. So yeah, to do this, we have like a robot file, like a bot that does that periodically. And it will just like look at the new builds that are pushed on the stable repository in Fedora, and bump those, like create the commit automatically. Once we have this, we have a scheduled test job that runs every day, and that's the first time pretty much that we're going to try to build a new version of Fedora CoreOS with the new content. So you can see it's a Jenkins pipeline. So we got like different stages. We fetch the new content, build the new OS3, signed OS3, and then we build the QEMU image to start to do our testing. In Fedora CoreOS, most of the tests that we are doing, it's using Cola, which is just a test runner that we maintain and develop. And in the happy path cases, everything works. And sometimes there's just like, we start to have like tests that are failing. So at that case, there is quite a lot of investigation that needs to happen to understand, okay, with like the new updates that we've consumed from Fedora stable, what has changed to cause the failure in the Fedora CoreOS test. So if we go back to like the release process, you can see that the feedback loop comes quite late in the process. We really only start to test for FCOS quite late. So if we have to make any change, or if like an update in a package is actually breaking tests for Fedora CoreOS, we can only provide the feedback a long time after the packager did the work. So what are our options in the release engineering? We have 3 options. So if there is a failure first, it's like the investigations. So we open a bug, say, okay, this test started to fail, start to look at it, try to do the diff, okay, which packages have changed, which package could be the cause of the failure in the test. If it's an upstream issue with the update, we can just then file a Bugzilla or GitHub issue with the upstream. So yeah, like this is a recent case where a change in systemd broke Fedora CoreOS. So we'll report the issue, it will get fixed and upstream and then flow down in Fedora. We have the possibility also with our test runner to snooze test. So if we see that the test starts to fail, but it's not necessarily something very important that we don't consider is going to break the stability of the system, we can say, okay, let's snooze or like ignore that test for the next week or so by the time to get it fixed. But we are not going to block the release. If it's a package or a bug that is a bit more important, like for example, like the systemd one, we have the ability to lock the package to a previous version. If a systemd update is breaking Fedora CoreOS, say, okay, we have identified a bug there, we're waiting for upstream to fix it. But for the next release of Fedora CoreOS, we're going to release Fedora CoreOS with the previous version that was working of systemd. So that's where the log files that we have, the system of log files is quite useful because we can then play with the versions that we release to users and keep that stability. We have also the ability of fast tracking an update. So if we know that a bug fix that we are waiting for is already in body, waiting for people to test it, and it has not reached the stable repos already, we can fast track that update and take it from body. We can like reference the body update and take the actual version and release this in Fedora CoreOS before it reaches Fedora stable. So that's where like also we have like all those different streams for users. Users will be very familiar with the next testing and stable streams, but we have also development streams. So we have a raw-hide stream that really try to get us like an early feedback on the changes happening in raw-hide. So we try to test early and get to see what is going to break Fedora CoreOS in the future. And we have the next devel and testing devel, which is where a lot of like those nightly builds are happening and where we run our CI and the test. I think we consider it a little bit like our main development branch. It's where like the development is happening. And yeah, for user, the next and testing streams are really where we encourage people to test and provide feedback and tell us in advance like if something stopped working for their system or their workload. So what we would like to try to improve in the next Fedora releases, it's how we can try to upstream our testing. And it's all about feedback loop. I talked a bit about that. And I quite like this thing. It's like when are feedback loop better? When they are shorter. As we seen previously, we were only testing quite late in all the process. And here the idea is to try to provide a very early feedback when the packager is building his package in Koji, trigger a Fedora CoreOS build, run a subset of our Fedora CoreOS test, and loop that feedback back on the body update. So the packager would know when he creates the updates in body if his update has impacted the Fedora CoreOS build or not. The idea is really to try to reduce a lot of the effort that goes into investigating why the tests are failing late in the development cycle and have the feedback directly on the update. So instead of having to look at which package was the root cause of the issue, or like to do some diff and look at the differences, we would directly know in body. We would be able to see, like, okay, when systemd or the latest kernel came, it actually broke that test for Fedora CoreOS, and there is a lot less investigation needed. So how would we be able to do that? Actually, it should be relatively easy. It's like between quote marks, but a lot of the infrastructure is already in place because we already have like testing on updates, and it's about like trying to plug our Fedora CoreOS release engineering testing to plug that into the rest of the testing infrastructure used by Fedora. So there is a system called ResultsDB, which is really a database with all the results that are, with all the test results that are run on updates and on compose. So for us, it would be interesting to do, to look at updates, and when pretty much when the Koji build is started, or when the Koji build is successful, we would have like a Fedora message that we would catch, trigger our Fedora CoreOS testing, and report the result of those tests into ResultsDB. And then body is able to, body will be able to get the results through ResultsDB and display that on the update. So this is already working for other tests. And you can see pretty much here, for each update, we already run quite a lot of tests for just like other variants of Fedora. So instead of having, for example, update-based system logging, we could have like something like update Fedora CoreOS, like kernel test or whatever. So like the packager would be able to see on their update if there is any failures, or like if there are any also required tests that failed, and so on. So for if you are not familiar with like the tests that have like a small star or asterisk, are tests that the packager marked as required for the update to be able to be pushed to stable. So that's like the gating. Yeah, Adam?
They're not marked by the packager.
Okay.
That's a distro-wide policy for those specific tests.
Okay. So yeah, so they are not marked by the packagers, but they are like distro-wide policies where there are like some gating required tests for updates. So, thanks. So yeah, the big difference is that we would run all the Fedora CoreOS tests before the packages are committed in Fedora repos. So if it breaks Fedora CoreOS, it would not reach stable, and it would let the packagers get that early feedback and know how their update impacted Fedora CoreOS. And it avoids a lot of like later work into communication, going back, say, okay, yeah, this was already unstable, but it broke that build, like, can we get it fixed, and so on. So it's really trying to save a lot of time for people working on packages.
So so how do we gate packages that fail in CoreOS CI tests? So we enforce passing Fedora CoreOS tests before pushing updates. So it's critical to make RPM OS3 variants a first-class citizen in Fedora. This will benefit from RPM OS3 based variants like CoreOS, IoT, Silverblue, etc. So future considerations, so building a common and minimal shared Fedora core minimal OS3 image, either to use as a base for other variants to layer packages on top of, or it could be used to create other OS3 commits. Okay, and thank you very much. And does anybody have any questions?
Is it on? Yep. So I have some more detailed things which I'll come and talk to you after, but I'm curious, how long does your pipeline take?
So it all depends how much testing we want to do. I think the idea for like the original idea would be to run just a subset of core tests that we think are important. And it would probably, I don't know, be less than an hour, like between 30 minutes to an hour.
That's good. Thanks.
Thank you for providing us insight into how Fedora CoreOS works. So since my background is providing feedback like from downstream to upstream, I can see that's an improvement, what you proposed, to provide feedback when the build is done. But honestly, I don't think that's enough. Like, I feel that in 1 or 2 years, we would be seeing presentation when you go even further. So I'm just like thinking about if we could do something better, like, for example, providing that feedback when the upstream release is created, or even in pull request, or like going that far.
Yeah, I think that's that's definitely maybe a talk for the next 2 years. There's a saying that I like, it's like, how do you eat an elephant? It's like 1 spoon at the time. So like that's the small step forward to, I think we're in the situation where we really want to try to like integrate a bit better. Like, as I said, the infrastructure is there already. So this is maybe like a low effort, high impact step that we can take forward. But yeah, I definitely think that this shouldn't be the end of, like, if we put that in place, that shouldn't be the end of the effort, and like go even more, like shortening even more like the feedback loop. Yeah, definitely.
So I have a question. So I don't, maybe it's too in the weeds, but and feel free to say that. I can talk to you guys after. But with the Podman desktop team, so we rely on FCOS for delivering Podman on Mac and Windows. And one of the issues we run into sometime with releases is Podman desktop has a release cycle, Podman does, and FCOS does. So what ends up happening, like when Podman 4.6 came out, it seemed to just have missed like by a day or two an FCOS release. So then we're waiting for it to go to stable and Bodhi for like a week. And then the next FCOS release is another, and it's like we've made a release and then our users will not get the latest Podman that release announcement went out for like a month. And I'm just wondering, I'm intrigued by your new model of having an additional test build. And I'm wondering, what are the implications there? Can that somehow help speeding this up, or is it orthogonal?
I think what will help a lot is, so it's not necessarily tied to the feedback loop and doing our testing earlier, but it's more like having a minimal Fedora core OS3 image that could have like a different life cycle, or have like just follow the normal 6 months release of Fedora, and you get the updates just like normally. And this could be like a base for all OS3 systems, so Fedora IoT, Fedora CoreOS. It could become like what actually is consumed by the Podman desktop team. And yeah, I think that could be something to explore if it fits better. Like the life cycles and release cadence is a tough topic, I think, to try to align everything. But yeah, I think we have some ideas around trying to have like that core set of packages that is useful in all and that could have a different life cycle or like consume the updates in a different way.
One mother, I see that's a future consideration. Does that mean will happen or?
I think we definitely have the idea to do it. So you know, it's still like the CoreOS group is still part of the like change process and so on. So that would be something we have to propose to the community, to have discussions and see if there is interest. And but yeah, that's definitely something that has been in people working like very closely to CoreOS' mind in the last few years. So.
Thanks for the presentation. I have two questions here. So first up, how would Fedora Core be exactly different from Fedora Minimal, except for the base that is going to be OS3 based? So would there be significant difference between what Fedora Minimal today is and Fedora Core would be?
So when you mean Fedora Minimal, you mean like the container image?
Yep.
First, there will be the kernel, since in the container image you don't have the kernel. But yeah, that could be a good start. It would differ from Fedora CoreOS in terms of, like in Fedora CoreOS, we have a lot of, so for example, we have Podman, we have Docker, we have things that are very opinionated to run containers, where in the Fedora Core Minimal OS3, we would not necessarily have this. I think we would look at what's the bare minimal to have an operating system that boots almost, and then let users or different working group or editions customize that to their needs. So yeah, it could be like the package set that is in the container minimal image could be a good start for that.
Okay. I have another question, which is currently when Cola tests, they kind of upgrade, if you will, from one particular stream to another particular stream, like 38, 39, so on and so forth. But with automatic updates, you can go from 35 to 39 all the way. But in recent past, that has failed. Like there was an error with migrating from 35 to 39. So is this going to fix it?
I think so when we have like updates, like for example, yeah, as you mentioned, like from 35 to 38, so there is a mechanism that I didn't put in the slide, but we have like a barrier release, so we can force the system to go through a specific update. So we would have like, so you wouldn't jump directly from 35 to 39. We would first update the system from 35 maybe to 36 because it needs to happen, then 36, 37, and so on. So we have that concept. In terms of having earlier feedback preventing that, I don't think that's like that would be like the end goal, but that might help. I think like, you know, if we are able to catch like bugs earlier and prevent package to go to stables because they broke some of those updates, that would help. But I don't think that would be a catch-all. I think we could still have like cases where like yeah, switching from a major to another major would bring some issues.
All right, thank you.
Anybody else have questions?
A lot of questions.
I walked in right during the Count Me thing, which is relevant to my interests. Do you, and this connects to Podman Desktop, do you have a estimate of how many of the running CoreOS systems reporting in there are Podman desktop?
Nope. No, yeah, it's hard to. Well, you know that. It's hard
you had
to
a
differentiate.
different way of knowing the Podman desktop thing from the Podman
Yeah.
metric.
No, because they just use like a stock Fedora CoreOS image, so they report as CoreOS. I wonder if we could try to do some. I'm just wondering now in which segment they sit. Like, are those systems that lives longer than 1 week or not?
No idea.
Yeah, I'm not so sure. We can. I think maybe like this we could try to get some kind of rough ideas, but we don't necessarily have like a very.
So if we move to that core minimal image, then could that be
That
built
could
as
be,
Podman
yeah.
machine with some kind of metadata that then you could track it?
Yeah.
Any other questions? Give me a workout.
Thanks very much. This question is a little tangentially related to the talk, but there's a request for Silverblue support on a new platform. And I'm thinking if we started working on that today, it might be...
On which platform, sorry? On Silverblue?
It's specifically the Asahi platform, but it could be any platform. That's just an example. So I've seen Colin do a couple of talks on Bootsy as the new way for OS 3-based operating system. If you're porting some of this OS 3-based stuff to a new platform and say you're thinking it might be ready Fedora 40-ish, should you bite the bullet and start looking into Bootsy, or? I know that's bleeding edge stuff.
That's a big topic. So I don't know how many people are familiar with like the work that Colin Walter's been doing. There's two topics, like there is Bootsy and OS 3 native containers. I think what you're mentioning is more around like OS 3 native containers, which the rough idea is that you treat your operating system just as an OCI container. So you would have a base. So coming back to this minimal core OS 3 definition. So this could be like a Fedora OS 3 core image that we provide as a container image, which is an OS 3 system. It's just an OS 3. It's all the root file, the rootfs, the root file system of your system. And you can just use that in a Docker file. So you would say from Fedora OS 3 minimal, and then run your command in your Docker file to customize that. So if you need a specific kernel for a specific platform, you could then like RPM OS 3 replace the Fedora kernel with the kernel that you need for a specific platform and so on. So there is a lot of work happening now around this. It's still a bit fresh, but I think that's like the future of, that's definitely the future of how we want to release all, at least Fedora CoreOS, but I think long-term all the OS 3 variants. And Bootsy is related to this in a way where this is what allows you to install and deploy those container OS 3 images. Like, so they are linked, but not necessarily like the same thing. So Bootsy would mean that you can start from any like Fedora variant or editions. So you could even start like from your Fedora workstation on the platform, use Bootsy to convert that Fedora workstation into Silverblue for that platform. I think that's another talk. Where there is a lot of details to go
Okay,
into
yeah.
that. But we can
Thanks very
talk
much.
about it if you want after. Yeah.
Any other questions?
Awesome. Thanks, everyone.
So, hello everyone, my name is Laura, I'm from the Packit team, and today I'm here with Simon from the testing farm team. We both work in Red Hat, and today we will talk about Packit and testing farm and their integration together. So, let's start with some agenda for today. Firstly, we will very shortly talk about Packit. Then we will switch to the testing farm. Simon will explain testing farm, its users, how it works. Then we will switch back to the Packit and deep dive into its features. Then finally we will talk about Packit plus testing farm and their integration. And we will also talk about the use cases, the users, and in the end we will show you some numbers, graphs, statistics. So starting with Packit, Packit is an open source project that tries to bring upstream and downstream closer together. And Packit has two main goals. The first one is to validate upstream changes downstream. So it's kind of a CI system that works in GitHub or GitLab. And then the second goal is to bring upstream releases to downstream and automate the process and make it easier for Fedora package maintainers. So as today we will talk about Packit mostly in terms of Packit service, which operates on GitHub and GitLab and reacts to the events in the Fedora dist-git. But there is also a Packit as a CLI tool that you can install on your Fedora and run it locally. So when last vlog happened in Budapest, Packit was in its beginnings and it didn't have that many users. But since then, I think Packit user base has grown rapidly. So here you can see just some of logos of some of our users. So for example, Podman, Systemd, Cockpit, NMState, and a lot of others. Yeah, so now I will hand it to Simon.
Thank you, Laura. So, I have some points to keep me on track so I don't get off into the weeds. So first of all, Testing Farm is a infrastructure as a service. It's a service that you can run your tests on and get results. There's storage for artifacts, there's queues, and so on. But it's more than that. Because you can run your tests on multiple OSs and multiple versions of those OSs and on multiple architectures. So it scales. Your testing will scale. Yesterday, I don't know, you guys probably, maybe some of you were at Adam Williamson's Fedora CI talk. He talked a little bit about how Fedora CI uses Testing Farm, and CentOS Stream Zool CI uses Testing Farm. That's in a public ranch, and there's also a Red Hat ranch, which Red Hat, all the rels are tested on. You can actually use that ranch as well. You apply for permission to use it, and you change your configuration in Packit, and you're actually able to run your tests in the internal ranch too, if that's allowed. Of course, Testing Farm is used by Packit. So Testing Farm generally, there's lots of moving components, but there's one API endpoint that your test is submitted to. You submit a JSON request, post request to the API. Then the ranch is selected. Your request waits in a queue. It gets picked up by a worker. The system under test gets created, installed with the fresh OS of your choice that you specified. And then the pipeline starts to execute your tests on that fresh system. The plans run, and the results and the artifacts are stored, and you can access these even after the the VM is destroyed because, yeah, that's in artifact storage. So you may ask, what's the benefit? Why should I use testing farm? You know, I could probably hack something together myself. Yeah, you probably could. The benefit to using testing farm is that, well, it scales to all the different versions of OSs, but also you don't have to maintain that infrastructure. You don't have to pay for it. So testing farm is, next slide, is it? Yeah, testing farm is open to any Fedora or OS Stream contributor team or special interest group. Testing farm is also open to any public project, service, or initiative which Red Hat or Fedora maintains or co-maintains. And of course, testing farm is available to any Packit user. Where was I? Yeah, so testing farm can be thought of as a backend for CI. But first, yeah, we need to talk about TMT a little bit. TMT, in order to use testing farm, your tests need to be managed by TMT. I don't know if any of you have seen or used TMT before. TMT stands for Test Management Tool. And there is the notion of hierarchy and inheritance. So these are two things that TMT will allow you to do really well. You can have core attributes that your test is, all your tests have access to. A very simple example is like a version number or something. And then you have your tests and you have your plans. And then there's stories. So stories are more something that is optional actually, but at a minimum you'd need tests and plans. You need one test and one plan at a minimum. But stories will help you to know why you wrote the test, why it's written that way. Do you really want to optimize it? Do you really want to change it? Was it written that way for a certain reason? It'll help you to understand your tests and, of course, other people to understand your tests as well. So yeah, TMT also runs locally on your computer. It's a tool. So you can, yeah, that's how you would develop your tests. You would first try it out on your laptop, see how it's going. TMT will create the SUTs, the system under tests, using VMs or containers. And that's, yeah, you don't need to, because of that, you don't have to worry about cleanup, because once the test is done, it'll just destroy the VM and not contaminate your laptop, your workstation. One thing to know about TMT is that it's not restrictive. You can write your tests in any language you want, in any testing framework you want. Basically, you just have to call it with TMT for it to be able to run in testing farm. So say you're using PyTest or something, just call that test through a wrapper or whatever you like, and then it will run. So it's a test management tool. It's not a test writing framework, so it's very flexible. Another thing you can do is so when you submit a test to testing farm, part of the request is the location of where your tests are. It's a URL where your code is in a Git repo, and in there it expects to find a plan where your tests are. So you could actually have just one plan in there with a URL to another repo where all your tests are actually there. So you don't have to technically keep all your tests with your code if it doesn't work out for some reason. Yeah, so actually, yeah, one more thing to note with testing farm, you have all that scale, but with Packit, you have even more scale, and Laura's gonna tell us more about that.
Okay, so in the beginning, I mentioned two main goals of Packit. So now we will deep dive to them. So we will start with the Packit as a Fedora release automation. And so that I can explain it, I will very shortly go through how does actually the new code get to the user using Fedora operating system. I assume everyone knows this process, so just very shortly. At the one end, we have the upstream, the code, and on the other hand, we have the user who wants to install the latest, greatest change. So there is a release that can happen, for example, in GitHub or GitLab. And then as a next step, the source code needs to be stored somewhere. And for that, there is a look-aside cache, which can simply be archive database, let's say. And then we have the distribution Git, which is in Pagure. There are the package-related files, packaging-related files. So we have spec file there, the sources file, and these needs to be adjusted to the new change. There is, of course, the Koji as a next step, which is Fedora official build system. Bodhi, the Fedora update system. And after Bodhi, here comes the change, and user can install it via DNF, for example. So how does Packit fit into these steps, and how can help with these steps? Here you can see all these steps in one screen, and actually on the right side you can see how Packit covers everything in the middle between the upstream and the user and the installation of the new software. So Packit has basically some jobs that can be configured, and for the Fedora release automation there are 4 jobs that can be configured, and they cover syncing the release, building the updates in Koji, and then bringing these updates to the Bodhi. So let's start with the first one. Firstly, we have the syncing the release. That means we need to bring the changes from upstream to the downstream. What needs to be done is that the archives need to be uploaded to the look-aside cache, and then the spec file needs to be updated, probably the version, the changelog, and the sources file as well. And for this, you can use one of the Packit jobs, either propose downstream or pull from upstream. And you will choose based on multiple factors. So if you are an upstream maintainer of the package, you can configure the propose downstream. Propose downstream is configured directly in the upstream repository, so you need to place the configuration file in the upstream Git repo, and then Packit will react directly to the release in GitHub or GitLab. The benefit of this is that Packit also provides you the feedback, the results directly in the GitHub or GitLab interface. Here you can also see the snippet of the configuration. So this needs to be placed in your upstream. And then you can also see a screenshot how Packit provides feedback about the job. So the proposed downstream finished successfully. You will get a link, and you can then see the PRs created in this Git, which I will show you in a while. But then, of course, sometimes you have a package in Fedora, and you don't have access to the upstream Git repository, you don't maintain that code. But in that case, you can utilize the pull from upstream. For pull from upstream, the only thing that you need to do is to place the configuration file directly in this Git. You will add the pull from upstream job. And after that, Packit will react to the upstream release monitoring messages and will do exactly the same process. So it will bring all the changes to the to the Fedora dist Git. And as I mentioned, here you can see on the screenshot that this is the PR that Packit opened. You can see that the version is changed, the changelog is added for the new version, and also the sources are updated. Okay, so what's next? After the maintainer of the package reviews the change, the PR in the dist Git, and is satisfied with the result, he can wait for the CI, and if everything is green, he can merge the pull request. But then, of course, the new changes should be built in Koji. And it can be tedious to do this every time there is a new release, so Packit can help with this as well. The only thing is, again, in this Git repository, add this little configuration for the Koji build job, and after that, each time the pull request is merged in this Git, Packit comes, takes the changes, and builds them automatically. Here you can see some packages built by Packit in Koji. Okay, but there is also another step, and there are the body updates, again, manual step, and it's very repetitive. So how can Packit help? There is the body update job. So again, code snippet, you can put this to your configuration file, and Packit will watch out for the successful Koji builds, and once there is a successful Koji build, Packit comes, takes it, and creates the relevant updates for the particular release. Okay, so that was it for the release automation. And now let's check the other aspect of Packit, and that's Packit as a CI solution. So previously, when we were talking about the downstream automation, mostly Packit should have been configured directly in this Git. But if we want to use Packit as a CI solution, you want to validate the things in upstream, so the setup needs to be done there. So firstly, you need to enable the interaction with Packit, and that's either in GitHub. For example, here you can see the screenshot of the Packit GitHub application, or in GitLab as an integration. So you just do a few clicks and install Packit in your namespace or repository. The next step is that your namespace needs to be allowed, so you just provide your Fedora account system login, and we do the automatic matching. So very quick step. And then almost the last step is you create the configuration file. There you place what you want Packit to do for you. And if one of the things you want from Packit is RPM builds, you need to also place RPM spec file, or at least add some script how to obtain the RPM spec file. Okay, so after setup, what can Packit do for you? The most used job that Packit can do are the RPM builds. So for the RPM builds, Packit uses the Copper build system, and basically you can configure Packit to build your RPMs for any pull requests, commits, or releases. And then, for example, if you configure Packit to react on your pull request, with each pull request, Packit comes, forwards the new code changes to Copper, the changes are built there, and Packit provides the feedback about the builds in GitHub again. As you see on these screenshots, we provide you links to the Copper web UI, the logs, and everything you need. One more note, so with RPM builds, you can either validate your changes, but also, for example, you can configure the builds for the pushes to the main branch or for the releases, and then you can have some dedicated Copper repository, and users can consume the builds from there directly. Other CI jobs that you can configure are the VM image builds. So these are the follow-up of the RPM builds, and if you want to also create the VM image build, then you just place a simple comment, as you see on the screenshot, and Packit will come, check whether there is the build RPM, take it, and create the VM image build for you. For this, Packit uses the Red Hat image builder. So you can see in the screenshot, you will again get everything you need in the GitHub UI. You have the links there, the status, and you are good to go. And finally, what we are here for are the tests. So as you probably got now, Packit uses testing farm for the tests, and the configuration is very similar to the other jobs. So how does this work? User enables Packit, as I previously talked about, sets it up in the upstream, then optionally also configures the build job. And after the RPMs are built, Packit forwards to the testing farm the package NVRs of the copper builds, sends the request to the testing farm, and then checks for the results. Once the results then the Packit provides you the feedback, again, as you've seen in the screenshots. So as for the configuration, the test can be, again, configured both for pull requests or the branch pushes, or also for releases. You can see that the configuration is really simple. So you specify the trigger, and then you specify the targets you want to run the tests on. So let's have a look at more use cases, how you can utilize the tests via Packit. So as Simon already mentioned, there is also a Red Hat range of testing farm, and it is really simple to utilize this via Packit. It is basically a one configuration option, and there's the use internal TF. So you enable this one, and of course you need to reach out to us. We need to allow you so that you can use testing in the Red Hat infrastructure. But that's it, you're good to go. Then, for example, if you have some really resourceful tests which you don't want to run on each pull request, in each push to pull request, but you want to run it only manually on a command, you again specify one more configuration option, and that's the manual trigger. So after that, if you are ready to test your changes, you can just post a comment, and Packit will react to that. Another useful thing that can be done via Packit is that basically there is this configuration option TF extra params, and here you can specify anything you would specify in the request to the testing farm. So one of the things you can specify is some additional artifacts. So if you want to do some reverse dependency testing, cross-project testing, you can just specify some repository in the artifact, and we will send these parameters to testing farm, and you can ease your reverse dependency testing like this. Then there is another use case if you want to define some custom mapping between your build and test targets. So here you can see we have RPM build job, copper build job, and the targets are configured for EPL7 and EPL8. But you want to run tests then and define some mapping. So for the builds with target EPL7, you will run these on the CentOS 7 and Oracle Linux 7, for example. So it's possible to define one-to-one mapping or one-to-n mapping. And another thing that was already mentioned, if you have your FMF metadata somewhere else, not with your code, you can also specify the FMF URL that points to some other repository. And you can also specify the FMF ref. And yeah, Packit will forward this to testing farm, and everything will work. And now Simon will talk a little bit about the interesting Packit usage examples.
So when preparing for this talk, Miro and I looked through some of the stats on some of the users, and there was a couple more, but these were interesting, and they were running a lot of tests. The first one, these guys, Strimzy, they actually contributed to Packit. You can take a look at how they did it there. They documented it. Maybe you already read this. I'm not sure. But they don't use any of the building. They basically use the testing farm infrastructure to run their tests, but they don't do any building. And Cockpit, of course, uses Packit. They run the same tests that Fedora CI does, but they do it with Packit. And this project, Scupper, this is a default plan that will run if you have no tests defined. And so even just enabling the Packit service, the Packit integration in your repo, what you'll get is you'll get this sort of sanity check. It builds your packages and it tries installing them. So at a minimum, just by enabling it, you get that functionality. This project is using that. So there's several use cases. You don't have to use all of the functionality. At a minimum, yeah, you still benefit a lot. Statistics from Packit.
Okay, so just for the sake of having some numbers to show you like how many users actually use Packit. So you can see some numbers for the past year. So the most used job is the RPM builds in Copper builds. As you can see, in the past year, it was 76,000 builds. And then, of course, the testing farm usage. So there were more than 40,000 testing farm runs. And as I already mentioned, the downstream automation. As for the syncing of the release from upstream to downstream, there were more than 700 runs of the sync. And here you can also see the activity of Packitbot in the distgit. So you can see in the recent months really active, and also some badges we earned. And then we have the statistics also for the testing farm. So on the image below, you can see the numbers. So in the 2023, it is 680,000.
That's projected, so it's not the end of the year yet.
Yeah, so you can see it is really growing. And as for the distribution of the users of testing farm, firstly, we have the Fedora CI, but then there is also Packit with around the third of the usage of testing farm. So really nice. And if you would like to try Packit and testing farm together or separately, it's up to you, you can check out our documentation. So also Packit and testing farm documentation. And one more step, if you even want to contribute, we are very open about the contributions. So we will share the slides with you, and you can definitely check out the links. And we are really happy to help anyone who would like to do some contributions. As Simon mentioned, the Streamzy team helped us, and they implemented some awesome features. So, and the same applies for TMT and testing farm.
Yeah. So I just want to mention that testing farm, the code is public and you can contribute to it, but we don't have yet a nice developer guide or any kind of style guide or community guide or anything like that. So you might feel a little bit lost, but if you have the confidence and you know what you're doing, go ahead and make merge requests. It's up to you. But there's no, we don't have it very welcoming yet, so to speak.
Okay, and lastly, get in touch with us if you are interested in anything we have talked about. Here are some contact information, so matrix, email, and we have also a Mastodon account. So yeah, make sure to get in touch with us. And now it's time for your questions, if you have any.
Thank you. I have a question probably related to testing farm. If my test requires a specific hardware, is it possible to define somehow or?
Yes, there's if you look at the TMT documentation, you can see that you can specify specific hardware. In the public ranch you'll have access to x86 and ARM. In the internal Red Hat ranch, you'll have access to Beaker, which is full of interesting hardware.
So this is not just about VMs, but I can say
No, you can use bare metal.
Okay.
With Beaker, there's bare metal access. With the public ranch, it's only VMs,
Okay.
just for cost.
All right. Yeah, I see. Thank you.
Yeah.
Are there any resources for learning about how the, which is the FMF is the syntax and the TMT is the tool? Is there
Correct.
any resources for how to actually use FMF? Because I guess the way it works is a bit different than other traditional CI systems work.
So you don't really have to, FMF is technically like a library, or it is a separate project, but you don't have to know about it. The documentation for TMT is sufficient to help you to use test management tool. And it's YAML, it's not very complicated, and maybe I can go back to the slide. Yeah, if you go to the, do we have, oh, we don't have a link to the TMT documentation. I guess if anybody's interested in that, I'll send it to you. But you can just Google TMT and you'll find the documentation. And yeah, it should help you get started. Yeah, if anybody's interested, maybe we can do a workshop later or something. Any other questions?
Okay, so if not, then thank you for coming.
by Don Nero, Scaling the Ansible Community to New Heights. Good luck.
I'm pleased to be talking to you today about some of the work we've been doing on the Ansible community team to basically help grow and strengthen and sustain the Ansible community. And I'm going to start out with some intros of our team, some of the things we're going to talk about today. By the way, the slides are in they're linked in the schedule, so if you want to grab them there, you can find them. So, the Ansible community team at Red Hat, we are all kind of funded positions to work with the Ansible community, and I thought it'd be great to introduce some of the people that do some of the work that I'm going to talk about today. So there's Andre. He works a lot with collections. He's been doing some great work with execution environments and doing a lot there. There's Carol, who is really kind of, she's almost like the engine of the team. Like we'd be nothing without Carol. Carol does like amazing outreach, organizing events, and is just kind of almost like our spiritual guide. There's Anwisha, who's the release manager for the community releases, and she also does great outreach. She's very active there, and just all kinds of things. Then there's me. I don't know, sometimes I just try and make it look like I do stuff. Carrying on, there's 8 of us in total. There's Greg, who's the team lead and community architect. Just unbelievable insights and experience from Greg, and really he's awesome dude. There's Sandra, who's the docs lead, and she's also kind of like a project manager for us and like helps keep us on track with a lot of things. Leo from Argentina, who does like a lot of also outreach, and he's working on labs, and he gets involved in some of the schools with Red Hat ambassadors. I'll tell you a bit more about that. And also Walter. Walter is, he's kind of the guy that helps us interface with Red Hat a little bit. And he advocates for us, and he helps make sure that like we have, and when I say we, the entire Ansible community, have the direction and support that we need from Red Hat to succeed. Is really a critical role there. So one of the things I'm going to start talking about, this is all about like work that we've done in the past year to build and grow the community. And one of the things, like if you go to Ansible.com today, you'd notice that there's a lot of Red Hat focused content that's about the platform and products that Red Hat sells. And there's not a terrible lot for the community. It exists, there's a community page. But what's been missing is this central place, like where can the Ansible community come online and have discussions. And I think like one of the things we've been dealing with in the community is a lot of fragmentation. And this comes in like different ways, like Ansible.com, but also discussions. There are things that happen in GitHub issues, GitHub discussions, and there's lots of decisions and chats that happen in these various places, and without having a central space, it's hard to kind of have a view into everything that's going on. It also makes it extremely difficult to know when a community decision happened, to have like a historical record. When you get several years kind of down the line from a decision, and it's like, well, how did this come to be? And you kind of, you lose that record. That's an important thing for the community to have. So we've been building a community website. Again, the links are in here. We've got some fantastic help from the Fedora community. This is places where things have come together. Mo, who's here, has graciously given us some great advice to help us get started. Also, like Michael Scherer, gave some great tips. We were choosing a static site generator, and like, look, static site generators come and go. We've had to rebuild things in the Fedora community a couple times. So what's important is, you know, you like kind of like abstract the content away from that and, you know, choose tools that the community uses and meet them where they work. So, you know, we've going actually with Nicola, which is built in Python and uses Jinja templates, and, you know, it's all familiar tools and tech for the Ansible folks. So this is the wireframe, but if you go to our repo, you can see the work in progress. It's deployed to GitHub Pages. You can join us on Matrix if you want to get involved. We're going to start building out the kind of the final thing based on wireframes that we've got. And this will like serve as that central point for the community in the web, where you can like get access and know where to go and kind of have a home on the internet. Along with this, we're launching a community forum discourse. Greg, again, has been spearheading this. I think he's wanted this for years, like 4 or 5 years at this point, and it's coming together. And again, in kind of collaboration and cooperation with the Fedora community, and like working with CDCK, we will have a place where, you know, community discussions can take place, where we can have those, you know, records, historical records of decisions, and like have a lot of the discussions and community topics and votes that go on. They use GitHub, which is kind of, it works, but it's a little awkward sometimes, and like kind of the flow for like having a vote and then closing a vote and like closing the discussion can just be a little awkward. And it can be difficult for new people to get involved with that. So obviously having a central forum and a place to discuss all things in the Ansible community is going to be great. And that's coming real soon. So stay tuned. So another big part of the Ansible community and the team and the work that we do are meetups and events and all the outreach that goes into it. And we've Ansible community days. There have been a couple already this year. There's going to be one in Berlin soon. The community days are just, it's a time for everyone in the community, whether you're, you know, just individual contributor or not, if you're just a user, if you're an enthusiast, or even if you're a Red Hat customer, you can come along and, you know, talk about Ansible, learn, share, and it's a place for everyone to get together. The Contributor Summit is more an opportunity, I think, for contributors to come and talk to Red Hat teams and, you know, work with Red Hat engineering to, you know, find new solutions and all that good stuff. Some upcoming meetup and events. I already mentioned the community day, but there's, you know, there's stuff that's going on all over the place. DjangoCon should be really cool too. One of the things that I mentioned, Anwisha, she has created a meetup organizers toolkit, and this is to facilitate like the community to like with a set of resources that will help you plan and carry out Ansible meetups successfully. It's available here, and it's also something that would benefit the Fedora community. We kind of want to share this because it's broadly generic for anyone who wants to organize a community meetup. But this is something that like Anwisha noticed that like, hey, we need this. You know, people are trying to organize meetups, and it's not always going so well because they don't, you know, they might be new, they don't know how to do it. So hopefully this will facilitate a lot more in-person interactions. Leo, as I mentioned earlier, this is him at a university in Buenos Aires, and he's going in and working with Red Hat ambassadors to reach out to students. And, you know, Ansible is this great starting point for open source, and it's, you know, if you want to be a Python programmer, if you just like, if you're interested in like sysadmin, kind of like DevOps, there's something for everyone with Ansible. So getting into universities is something that Leo's just started, but it's really great work. It's, you know, so community releases. How many, just quick show of hands, because I'm doing a lot of talking, I kind of see people out there. I want to get a bit of interaction. I like some conversation. How many how many of you have downloaded Ansible from PyPy? You pip install Ansible? Really? Okay, there we go. I'm sure some people on, in the virtual audience have. Well, so that's the community release, and that involves Ansible core, a bunch of Ansible tools, for running playbooks, as well as community collections. And that release process has been handled by Anwisha Das. Since 7 RC1, she was the shadow release manager, now she's the release manager. She's been doing great work with those uploads and building and making them available to the community. And of course, we've had some help from friends along the way, like Christian and Sandra and the steering committee. Also, one of the things that this year this team has been doing is trying to open up more and give back to the community and give them the ownership of some of these processes, and making sure that they not only have visibility, but they can participate and they can drive this. And it doesn't have to come from someone who's a Red Hatter, and the processes shouldn't be behind Red Hat firewalls or whatever. And Anwisha's been documenting this process with the steering committee, and she's also been automating a lot of it through GitHub Actions and different workflows, so that it'll be easier for people from the community to get in and handle that process. One of the things I've been working on is what's become known as the docs lift and shift, and we kind of had this point where we were trying to get all these community doc initiatives going, creating new content, revamping stuff and restructuring. We restructured the user guide that was just this big honking chunk of all these different topics, and being able to retrieve and find information within that was a lot of work. So we decided to kind of break things up. So we're doing things like that to improve the doc and to get more contributors in through the documentation. And one of the things that we found was that some of the people in the core team, we were just kind of getting in each other's way a little bit, with their sanity tests and some of the things that the core team, some of the needs that they had didn't exactly align with what the community needed. And there's a lot of, there's all the documentation for, kind of the end user documentation, but also collections and stuff like that, and stuff that's owned by the Ansible community and the steering committee. So we've created a separate documentation project, and that's been a little controversial because some people think that documentation should always belong in the same repository as the code and the thing that it's documenting, and that kind of docs as code approach, which I adhere to myself. But we just kind of got to the point where it just made sense to create a separate documentation project so we can really accelerate some of those efforts. And so far it's been really successful. We've seen a lot of community engagement with that. So that's been great. We've been adding new workflows and doing all kinds of fun stuff there. Another thing that I've been working on is revamping the Ansible doc site. So the doc site, just to quickly kind of disambiguate the term that I'm using here, this is just a set of static HTML pages. It's kind of the landing page when you go to docs.ansible.com and you kind of navigate around. It's those top level HTML pages that are in front of the actual documentation once you drill down. So it's the main entry point for most new Ansible users. And at the start of the year, this is a snapshot, actually when I joined, I'm still fairly new to Ansible myself. And around May 7th last year, there were these big kind of cards that took up all this real estate, and they were focused more on, there's community, then there's the platform, the downstream offering, and then there was some core stuff. So it was more focused on kind of the tools and not really taking the user's perspective too much. So we decided to create a more user journey, user-centric approach. And to start doing that, we started identifying personas. And, you know, persona is just a representation of the user or the person who's looking at the content. And we defined a few. You can find them. They're here in Markdown, which we put everything in Markdown in the open, so it's in plain text, and it's there for contributors to look at, and it's not in like some kind of like slide or, you know, whatever. But we focused on the needs, the attitude, and the knowledge of the personas as well. We identified them, and then we said, like, you know, what do they need? What's the type of content? What's the attitude? You know, the attitude helps you determine the level of verbosity. You know, say like a Python programmer is going to want like all the programmatic options and their expected behavior. But if it's like an SRE somewhere, they just, you know, show me, like when the red light's flashing, show me remediation. And then the knowledge also helps you tune in more and like meet the needs, because, you know, a hobbyist is going to have a different set of knowledge than, say, like a solutions architect. So once we had our personas, we decided to like, what do we do with those? What's the next step? Well, I said I was new to Ansible, and I came over from JBoss. I've spent like a lot of my career in middleware for my sins in a past life, I think. But yeah, I was like really super familiar with Kubernetes, and there's this, you know, this for me is like the, you know, the Kubernetes journey, and it seemed like a very like sort of abstract kind of, you know, this could be applied, like these different milestones could be applied to most like projects with technology. You know, someone starts out, they become aware, then they evaluate, then they adopt, and they start using, then you scale out. So these milestones describe these progressions that you would kind of go through, and we decided to, you know, start with human motivation as the first thing. And we started mapping out like the journeys against those milestones for each of the personas. Again, we've got those in Markdown. You can check them out there if you want to find out a bit more. And once we had the persona journeys mapped out, like where they're each step to 10 minutes left. Is that 10 minutes? Sorry, just so I'm clear.
You're at or quarter past.
Quarter past?
Like 10 minutes,
yeah. Yeah, 10 minutes roughly.
But
Would be
we're
good.
running into lunch, so if you run over, it's fine.
Okay, yeah. I've got like 40 slides here. I've been practicing, so I'll try it. I think 10 minutes would be good. But hopefully you guys are into this anyway, and everybody's having a good time. But you got the milestones, and then the steps underneath them to complete them. And so we thought, like, so we've got these things, and we're gonna like build the new doc site based on these. So when somebody comes in, they're not gonna say like, oh, here's, you know, community docs, or here's platform. You're gonna see the entry point, and like, you're gonna see these journeys. How do you do something with Ansible? So once we had those things, we decided to make things available to the community. Again, we're trying to use tools and tech that the community is familiar with. I created this Jinja doc site. Naming things is actually one of the hardest things to do in tech, and I still kind of hate the name of that repo, but it's going to go away. But yeah, the Jinja doc site. And you know, when we started building the new doc site, you know, making sure the community get to it was vital. And this is actually the first thing that I came up with. I went wild, I went bold at first, and you know, part of the idea there goes back to Cunningham's law. We wanted to get feedback from the community, and if we release like, oh, here's this great, like really high polished site, and everyone's, yeah, it's great, but we wanted to hear, we're building this for the community, and so intentionally putting some things in there that didn't really fit, and like kind of like bold colors, and it seemed to work. We got a lot of really good feedback. Sandra, who I mentioned before, the docs lead, was fantastic, and going out to the community and finding out what she hit Reddit, like Matrix. We have this docs meeting, and she really, you can see her here, you know, but we got a lot of feedback. A lot of it was like super critical. A lot of it was like, yeah, this isn't so good, but we kept going. We gathered feedback through the Bullhorn newsletter, we iterated quickly over it, and over time you got more, and things started to trend more positively. And then we released our journey-based doc site. So if you go to docs.ansible.com now, you'll see there's like each of those kind of like milestones, and then the steps you need that are direct links to the documentation. So you just get in and you find where you're going much quicker, and it's more mapped to actual things that you're doing and your tasks. It's not mapped to like a product or a tool or something. But yeah, so this is what and you'll see there are sections for each of the personas that we identified. So that's some work that we've been doing. Along with that, we've actually done a lot with the documentation in the past year. One of the things that I noticed, particularly when I was joining and trying to like navigate around, was like there's this whole ecosystem of all these projects in Ansible. And it was very, they were all like, some of them were hosted on Netlify, some on Read the Docs, and some of them, there were even like third-party kind of like forks of documentation or like mirrors that were on Read the Docs, so you couldn't trust anything from like just looking at the URL or looking at it. Is this Ansible or is this like this third-party thing, which, it's fine, but it's hard to know if it's, I guess, official or whatever. And, they're like markdown and like some repos. So you get the idea. There's docs all over the place, but it's hard to know what is Ansible community and what is not, and what can I trust. And it all looks different. So one of the things we've done recently is we got the Ansible namespace and Read the Docs, and we put all the Ansible projects under that namespace. So now it's like a consistent URL. And if you go to Ansible Read the Docs, you can see all the projects that are in the ecosystem. They have like, deterministic URLs, and there's also community themes that we've been applying, so you get a consistent look and feel while you're browsing the documentation. And this really helps to kind of build trust with the community and create this cohesive identity. We've also been working on removing barriers to entry and making sure that community users can get in with Ansible and start, get up and running like quickly. Again, it's something like coming from like the JBoss world of, you go in and like the first thing you see is like a hello world. And when I joined, it was like, I went to Ansible, docs.ansible.com, and it's like, where is that? How do I start using Ansible? And there's like a link to a quick start video that went to a Red Hat site, and the video didn't load. And then there was another link that took me back to docs.ansible. So there's this loop. And I remember spending about like 10 minutes just trying to answer the questions like, what is Ansible and how do I just even use it? So, even starting quick start guides and getting started. Andre on our team has done a fantastic job, and he's, execution environments, which it's just basically it's like a container image that kind of acts as the control node. And this is something that we noticed was causing confusion for the community, and like a lot of people didn't even know like what an execution environment is, and it's this thing that gets talked about a lot more kind of downstream than in the community, even though it should be available to the community. So we've been working on that as one of kind of our points to fix and make it easier for community users to get in and start using stuff quickly. Also, Leo has been working on community workshops. You can find a couple there. They're a little bit out of date, and there's a Red Hat one that is kind of mixed with AAP stuff, which is, it's all good to learn from, but it's not quite Ansible community. And we've got some new stuff that's coming up with Instruct Labs based on like new community users is one of the main personas, and then like more advanced users. So real soon we'll have a whole set of workshops that you can go online, and it's self-paced. Now, that's kind of a whirlwind tour of all the stuff we've been doing. One of the things that I wanted to do when I came to Flock, and this is actually my first Flock, but I've been a Fedora user for years now, and I've been having conversations and trying to talk to people, and like, how can we get Ansible, the Ansible community and the Fedora community to, come together? And we've learned so much from the Fedora community already, and we want more of that. I think like the toolkits that we've been working on would be great to have, Fedora community users using them, and even stuff like Ansible tests should run on Fedora. And I was talking with Kevin about all the Fedora infrastructure uses Ansible, and maybe we can help there to update some of the syntax and find some ways to improve it. So this is a direct call to the Fedora community, and just saying, let's let's hang out. Why not? And as always, we're totally open. Please come and join us. You can find us on Matrix. You can find us on Mastodon. You can subscribe to the Bullhorn newsletter if you want to get all the info about it, what's going on in the Ansible community. And you can also, you're welcome to come share your news and add to the Bullhorn. The Ansible Community Weekly meetings every Wednesday. There's lots of special interest groups. I mentioned docs. I know there are a couple of documentation people in the room, some tech writers. Please come and join us. There's tons of work. And if you're looking to get involved in open source, or if you're like really experienced but you don't know Ansible that much and you'd like to, come hang out with us. We're on Matrix. We're your friends. Thank you. Any questions or anything? Do we have time for that?
Time, but I think it's lunch, so we can take 1 or 2 questions here. If anybody has.
Well, you know where to find us if you do have questions. Thank you very much. Thank you.
We break for lunch now. Thanks, everyone.
So, good afternoon, guys. I hope you had your lunch and you're all ready for the next session. I'm Shumantro. I would be talking a little bit about Toolbx. And if you don't know what Toolbx is, I would give a brief intro of why we have Toolbx, what's the use of it, and preferably where we stand with the project. At this point, me and Debarshi, another guy, we both are maintaining Toolbx, RPMs and the images, and I'll go ahead and start this presentation. So, a couple of things about me. I'm Shumantro. I work for the Fedora QA team, and my primary job role is to test packages, images, as in the compose images, and anything which comes new as a part of test days. Other than that, I do few other things in Fedora. One of that is making sure that Council understands, or rather works with, whatever new community stuff we want to roll out, so objectives, Fedora ambassadors, and few other things. I also am somebody who coordinates outreachy in Fedora. So if you are willing to do internships in Fedora, that's one of the programs I coordinate. With COVID, that has not been a very successful one. But yeah, we keep having more and more projects. So if you are someone who is having, who wants to have projects, initiatives, or very small bite-sized tasks you want to accomplish, reach out to me. I coordinate internships as well with GSOC, as in Google, and Outreachy. So I would be able to help out. I usually hang out on Libera chat and a couple of channels that's mentioned there, and that's mostly what we have. So let's get started. First up. So a long time back when we started doing Linux distros, everything was based out of a specific packaging format. So you have the debs and the RPMs, and you would basically package everything in a deb RPM style. The problem is everybody's machine becomes or starts becoming a snowflake problem, which is if you have a machine and you're running Fedora something, Ubuntu something, and you have your own package set or the packages you use, it's very hard for me to debug what's happening in your machine. So if something crashes, it's nearly impossible unless you give me a full traceback of what has broken. It becomes very hard for normal general users to provide us with that much amount of logs every time they file a bug. Hence, most of these bugs that people file are marked as invalid, and they do not contribute much to us solving it, in short. So as a result, it becomes very hard for us to test what these problems are, how this problem started. Other things with when you have RPMs and debs, mostly these are packages, and updates are not really fault tolerant. So if you ever try to upgrade your machine and you run out of space, or your power goes out, or your battery fails, well, that's a whole different issue after that point, right? So historically, we had exactly these problems. And other problem is we had almost no separation between the apps and the operating system itself, which means, think about it this way. If you wanted to have the latest version of Firefox or latest version of Darktables on your machine, you would probably have the latest version of operating system. If you were to expect Fedora 39 to have X version of Firefox running, and even if until that's packaged for F38 specifically, you cannot really have it. That becomes a little challenging because there is no separation between apps, and you have to upgrade your entire production system just to support your apps. And that's a problem that has been there for a really long time. One advancement that we had a few years back was we started having these things called OS tree. Now, all of you who don't know what OS tree is, think of it like Git, but for your operating systems. So when a package maintainer or whenever a maintainer commits something, they actually package the entire thing under one hash. And every time you upgrade to that particular hash. So if something is failing, let's imagine a particular hash that we all are sitting in, and there is a very high chance if my Firefox crashes, your Firefox will crash as well. because we are sitting on one simple hash, and which means if I were to fix something and deliver you a fix, it is very easy for me to tell you, okay, that hash works, just upgrade it, and it would just solve your problem. That's a very simple way to detect problems and fix it, or rather try to find a root cause of it without going into what packages changed between last 2 days before the failure started happening on your system and you could actually register. So that started happening with OS3, and OS3 used to maintain a lot of Flatpaks and Podman apps. So all the apps with OS3 were very sandboxed. So technically, since OS3 is immutable, all the things came as a part of either Flatpaks or Podman. So all the client applications were Flatpaks, all server applications were Podman apps, right? And then it used to make life easier for most of the people who used to use OS3, or rather still use OS3. The only problem with OS3 is there's no DNF, and there is no, it's immutable, so you cannot really modify /user. I mean, you can do a lot of things, but that is not really how OS3 is meant to be used. Now, as a result, one of those things that we started talking about was how can we solve this? So like, for example, if you were a C++ developer or you were a Golang developer, you still need binaries. And those binaries are not in Flatpaks anymore. They are still RPMs, and you would need to install those RPMs. But without DNF, that's not really possible. So the other way that you could go around was installing that onto a container and then pulling that out from something. Problem is, when you use or keep using Podman for multiple things, you make your commands start getting like one sentence or one paragraph longer, like because it sandboxes its own self. And other thing is, when you try to SSH between Podman and Podman and Podman, now that gives you another level problems. As a developer, when you start building apps, you really do not want such things. So the simple implementation that we came up was to ensure that all these compilers, debuggers, SDKs, were kind of set up using one single place. And you wouldn't have to spin up containers after containers after containers for doing the same. Example, these were the few questions that a lot of people had. Last one is actually a hack that is layering works, but every time you layer, you restart. Every time you restart, well, you lose things. You really don't want to install NPM dependencies and keep restarting over and over. So yes, moving on, we started having a new thing called Toolbx. And that was the point when we decided Toolbx would help developers run all of these things inside a toolbox and use it system-wide however way you want to use it. That's the point when we started making Toolbx more developer or debugger friendly. So if you are someone who is debugging code and you do not have a particular system, like for example, I want to debug something for, or rather, I want to build something for CentOS, but I'm running Fedora. Well, my original option is to run a VM. Here's the thing, or a container, anything for that matter. But every time I keep running Podman and keep giving it commands and more commands and more commands, that's a problem. Also, a lot of integrations with systemd, Avahi, network drivers, they need to be explicitly set up most of the time. Toolbx, you don't need to do that. That's implicitly done for you. It increases the quality of life for a developer, and that's exactly how. So as part of Toolbx, we kind of have all these images that we are talking about hosted in registry.fp.o. Right? Some images come from accessfedhat.com, specifically the rel 9 images. So if you are somebody who is using a Fedora and you want to run rel for testing your code or building something, you can have a rel image. If you are on CentOS, you can have a Fedora image. vice versa. Toolbox makes it really easy for you to go ahead, have a container, a bunch of containers running very specific things, and then you can go ahead and run like your graphical applications, because it supports Wayland, you can run your graphical applications as well as your CLI applications, use it wherever you feel like. This is one of those things which we kind of started talking about for a long time from a developer perspective, very precisely. But very recently, we have also learned the fact that it becomes really hard when you are supposed to, one of my use cases back in the day was whenever I used to commit something for a repo, it used to, let's say that's a Ruby repo and I need a bunch of dependencies to run a lint. And I don't have 1.9 GB to give on my system for it to download things, and which I would probably never use after that point. In that case, I would probably have the entire thing run on a toolbox and then run whatever commit I want to have. That way, it creates a very simple separation between things that I don't want it one time and gone. And I can still, if I want, because it uses Podman on the back end, I can actually snapshot all of that, keep a tar of it, import it every time I want to use it and reuse it again with Toolbox, and that makes developer life easy. So a couple of things that we have decided with Toolbox, or rather, we kind of are trying to do with Toolbox. One thing is we are trying to go ahead and give you a very simple command line debugger for OS3 and OS3-based distributions, namely IoT, CoreOS, GNOME, Endless OS, and goes on. It is actually very important for adoption of these OS3 images, or rather OS3-based operating systems, because without DNF, a lot of the people who are actually working and developing apps, they wouldn't get the libraries they would want. Without the proper support of DNF, it is going to make adoption curve really hard for folks who are using OS3. Also, there is a major thing that a lot of our developers look forward to, which is whenever they run applications on, let's say, Toolbox, it is very seamless. It doesn't make your life revolve around multiple flags and parameters. I'll come to it how. So other thing is we have grown our code base, or rather the test code base, which is currently BATS, which expands to Bash automated testing, which is like 250 tests and it's growing. Mostly supports CentOS, Stream 9, Fedora, and Fedora Rawhides, and Ubuntu. Rawhide is the latest addition we have here, because Toolbox used to just get images of Fedora for last like 3 releases now. But in the recent one, we have added it to the workstation by de facto, which means the RPM would still be shipped in the workstation. The image won't be, but the image that you can pull this time with Toolbox is the 39 image, which is the latest image. And that's exactly what a lot of people in Releng are working. So Mikal is here, so thanks for helping us build that. All of this would also be moving to Quay.io in some time, so it would not be reg.fp.o like it is today. It will be moving out, and that's one of those primary goals we have with Toolbox. Now, that's mostly what I wanted to cover up. We are looking at 4 specific areas we want help from contributors, and that would be with test coverages. When I mean test coverage, this is exactly what I want to point out. We have the basic. Yeah, that's a fire alarm. Should we go out? Yeah. Yeah. What? Yeah, I think we are not burning. I mean, we are alive. We won't be burning. So, yeah, we are looking at actually test coverages. A couple of things on test coverages. We already have the basic test coverage running currently, which is fine, which is not extensive. It is just working and it is enough. But as we go on increasing the number of platforms, which is Arch, and if we move beyond Arch, which is Kali and rest of the things, we do not have batch testing enabled for all those. And we would want contributors to come and help us over there. Other thing is, as we go ahead, add more features to Toolbox, because it still uses Podman on the backend. We can actually do a lot of things with Toolbox, which are currently not being done, mostly because we want to enhance whatever is today, make it of a stable quality before moving on to giving multiple options that Podman can still expose for you, right? So essentially, we want to have those features, but for that, we need contributors who can help us write test cases and manage those, both on the manual side of things and on the automated side of things. OpenQA is one of a good place where we are trying to dump most of these test cases, which would automatically run it for Rawhide, because now it gates Rawhide, so it would be more easier for us to catch something which has changed, which then breaks Toolbox. That is one of the places. We are looking for anybody who is willing to go at their conference and talk about, because Toolbox is a very small piece of software. If you have a conference around you and you want to speak about Toolbox, get in touch with me or Rishi. We would help you with a slide deck which you can use to go ahead and talk about Toolbox in your local developer communities. Other thing is, we have a bunch of documentation, mostly upstream. We don't have things in Fedora docs yet. But if you're somebody who is willing to write documentation for us, reach out to me. I would be all game to help you write something. Now, the last part, and this is where it gets a little tricky. Toolbox relies on a lot of dependencies. And when I mean a lot of dependencies, it means if something changes in systemd, Podman, or rather whatever Podman depends on, it usually would break Toolbox. And Jens here has filed multiple bugs which has broken Toolbox previously. Some of these issues are easy to debug, and some of them are not. And this is where we would probably want you to test Toolbox with multiple OS environments and let us know if something is breaking, because that way we would be able to fix it in time. This is just me and Rishi working on it, so we still need more people to come up, help if things get broken. One more thing, Toolbox is blocking, which means if Toolbox is broken by some chance, Fedora workstation would be blocking it. In other words, we would block the Fedora release until that issue is solved. Which brings us to the point of how critical this can be. So having said that, that's mostly what I wanted to cover at the state of Toolbox, right? And I would leave the rest of the time for the questions. So if you have any and every question that you have around Toolbox, I'd be more than happy to take it. Yep.
I'm just wondering how well are these test cases working for you? Are they giving any interesting results? Or?
So the bash automated testing, the BATs, which is upstream, they give us some results, and those results are usually in a very binary format, which is either ones or zeros saying this particular parameter did not work at all, or this worked. And all of this is done using Fedora CI, so which is fine right now. But with the time, as we extend more and more features, I think we would want to rewrite some of these test cases, refactor them, and make sure something interesting comes up. But my concerns with the bugs are not coming from what test cases we have today. It is coming from a concern of if something changes in, let's say, Podman, it is supposed to break us, right? And which intently means that before, before chain sets are filed, me and Rishi will probably have to look through the entire chain set once and see whatever new is coming, and if that depends, or if that has a possibility to break Toolbox in some other fashion, like if there can be a regression on that. And we don't have a blocking policy for it currently, but very soon with the fact that Workstation would be blocking Toolbox, we have to look at bugs well in advance, which might be coming from a new chain set which has not yet been deployed to Fedora, but when done, that will break Toolbox for sure.
Toolbox is that sometimes very long-lived toolboxes can have problems, and I think this is quite difficult to detect in CI. So I'm wondering if it would be useful to have some kind of archive of older toolboxes or something, or like to test on. Yeah, it's a slightly tricky problem, but.
I couldn't get your question. Like,
well, the problem is that sometimes over time toolboxes stop working because of changes. So you can't detect that in CI easily. So I'm saying to have some archive of older images to older container. To test these things.
Yes. So that's actually a very, very nice observation. So the one CI that we run, we explicitly put it to Fedora 34. And we test Fedora 34 and see if 34 works. And then on a 34, we test, let's say, the last N+1. So the recent F37s and F38s, and CentOS 9s and RHEL 10s, or RHEL 9s, right? So in that way, we have one point of like understanding if Toolbox works with F34. If F34 works, then everything else works. Usually, if that test case fails, that's usually a direct blocker for us. Like that's one thing that is done by the CI right now. So if you were to look at, I don't know if I can. Let me show it. So yep. I don't know if this can be. So let me show you something. See that line? That's the one that got added very recently, but that's how we are like making sure. So there's an older version of RHEL as well, just to ensure that things are not broken. So we still have RHEL base image 9.1, like UBI 9.1, but we still maintain, or rather test it on the CI.
Thanks.
All right, guys. Yep.
Okay, my question is why Fedora 34? Because it's no longer supported and available.
Yes. That's actually 34 is not actually it's not very static. We can make it anything, but we want something which is outside the supported variant tree, right? So that we know that this used to work. So if something has changed between that and the latest image, right, then we know exactly what changed. Remember, the toolbox only comes with a very specific set of packages that are one-to-one compatible with the operating system that you use. So it probably won't have binaries like uptime on it, but it would definitely have things like DNF, which are like whatever you would find, use libDNF. If that's DNF3, you'll find DNF3. If that's DNF4, DNF4, and DNF5, then DNF5. But that would be one-to-one compatible with whatever. But we just wanted to keep it 34, to keep it outside the series that's supported right now, to ensure that we can have an understanding. Plus, this was done when we did not have rawhide. So this still doesn't talk about how we would test rawhide stuff. So the moment rawhide lands and we actually have something that is shown up on Quay, maybe we can add that as an image and see if it runs on rawhide. So it would pull base as rawhide and then try deploying whatever we want to, yes.
Thank you.
Yep. So that's mostly what it is. If you guys have any questions, reach out to me. Thanks for attending my talk.
one of the managers with the CoreOS team, and this is a workshop called Hands-On with CoreOS Assembler. So I'll start with a very short presentation about what's Fedora CoreOS, give a bit more context about what's CoreOS Assembler and what we use it for, and then we can step into like the lab. We have like a lab and a set of instructions that you can run to get a better idea and use by yourself CoreOS Assembler and start to build Fedora CoreOS. So quickly, Fedora CoreOS is a Fedora edition since Fedora 37. It's focused at running container workloads, so either on single nodes or in clusters. In clusters, it's used with OKD, which is the open source project for OpenShift, but with also other flavors of Kubernetes. It was the result of the merge between Atomic Host and the container Linux from like the CoreOS, the company. And it's really like a merge of like different technologies from those two projects. So in the philosophy, there are like three main points. Automatic updates, so we really want users to consume, to have like the latest security updates, to have like the latest version of their software, and we want them to have that. They don't have to care about it. It's going to be provided automatically for them by the operating system. Automated provisioning, so we want it to be very easy to provision like 1 or 1,000 nodes. They should all start the same, be the same. That's the philosophy behind that. And immutable infrastructure, so we want a solid operating system that you can control and where you provide updates that doesn't break, or you can roll back and have like a more robust update model. So in order to do that, the release of Fedora CoreOS is a bit different from other Fedora variants. We have like 3 streams, next, testing, and stable. And the idea is like if you actually run your workload on the stable stream, you also try to test in advance the updates that are coming in Fedora CoreOS. So we encourage our users to run also testing and next, so they can provide the feedback early, and that gives more chance to have like a very stable stream. All right, so a bit more, just like a few words about CoreOS Assembler. So CoreOS Assembler was built specifically to build like Fedora CoreOS and also RHEL CoreOS. And it's pretty much like a Swiss Army knife for like building a distribution. It contains all the tools and all the applications needed to build a CoreOS system. And there are like a few key aspects, like key design decisions that were taken when the tool was developed. First, it was needed to actually be able to run that tool on your laptop. Like you could just like use that tool and don't need anything else. So for that, it's running in container, and it runs on everyone's laptop. You don't need to have like some specific settings or so on. It's also the same tools that you use for like the development process, so that you can use in your laptop to develop, to build new features or test new features. And it's the same thing that is actually running to build the production builds, like that we use in the build pipeline. Yeah, and as you will hopefully see in the workshop, this is a great way to quickly iterate, and because it's so easy to build to use that tool to build Fedora CoreOS on your laptop, you can quickly make test changes, investigate if there are problems, and it's a very iterative way of developing. Any questions on that, or like before we start the lab? I just gave like a 5 minutes overview, but if there are more questions, I'm happy to go for. All right. Okay, so for the lab, we prepared like some lab machines in the cloud that you can access. I'll give you the details. If I find where my cursor is, here it is. Okay, so I'm going to give you a number that you can use here, like so lab user, and the X you just replace by the number that I'm going to give you. So we're going to start with number 1, 2, 3, and 4. So to connect, you can just like run in the command line SSH, lab user, your number, the IP address, and the password to log in on the machine. It's flock23 Cosa Lab. If you have any trouble logging in, just raise your hand and I'll come and try to see if I can help on it. Once you're logged in, so you should be able to follow, we have like the tutorial step on this address. So github.com/CoreOS tutorials. And then you can just look for the CoreOS Assembler file. Any issue? Or the typing? Yeah. Maybe next year we'll do a QR code or something like this, making it easier. So hopefully the tutorial should be relatively like self-service, like you should be able to go on your own. But yeah, let me know if there is any questions or anything that is not clear, not working. Don't hesitate, and I'll come. Say again?
This assumes you have UID 1000 ISD.
Yes. Yeah. But it shouldn't matter. Yeah. That's a good question. I don't think it matters too much for the build. Yeah. Yeah.
I don't remember which number is which of those, but I guess where it says 1000, it should be my actual.
Your actual UID, yeah.
Which happens to be 1000.
Sorry, say again?
Or did I misunderstand those ID mappings? I mean, in the bash function, yeah. Here it says 1000. And yeah, so it's a login, I get usually 1001. So should, if you replace it, if you 1001 and 1001, and here I should instead use a different ID map here. Mapping it to. So should I open it in book?
I don't think it matters. Yeah, it doesn't matter. Yeah, so you can just copy the. Yeah, you can just copy the function directly and don't care about the UID. Yeah. I think it might matter for some specific test or thing like that, but for what the lab does, it shouldn't really be significant. You can use user 5, Adam, if you want to do that. Okay, one thing that will matter, that's the good thing to do with multiple users. When we try to add only one user. Okay. In the lab, when you copy paste that function to use later, the COSA function. You need to put your user number behind the COSA name. So just like COSA 1, COSA 2, COSA 3, COSA 2. Because it's pretty much running containers in Podman. And you cannot have like the same name for like multiple containers. So you should be okay if you already done it. So. Let me know if you have like a weird error. I'll come. the first pull, like the first time you run COSA, it can take a bit of time because it's pulling the container and the container is quite big. So.
So fast, and I took 5 minutes.
Yeah.
Okay, just finished.
It's usually better, so the machines are on AWS, so usually it's fast, but it can depend. Anyone's got a build already, or did you manage to go? Yeah. Cool. Did you manage to get Fedora CoreOS build already after the COSA fetch, COSA build? Yeah. Not yet. Yeah. Cool.
And then start the name, which I'm trying to look at the image at the VM from the outside.
Okay. How do you? Should have like with libvirt.
I can see the QEMU process with
Yeah.
arguments. I'm just
Yeah, I
to
think.
see what's happening.
Yeah.
Okay, you don't remember either.
No, you can't really do. You need to go from inside COSA because you will have like so in the COSA in the container image, you have like all the tools installed to run the virtual machines, not on the lab. So if you see in the you have like the COSA run dev shell console. It's a bit Inception how it works. Because pretty much all the virtualization. Yeah. Yeah.
So if I execute it,
then you will be you will have like all the libvirt and all the comments. That's really what that was one thing for like one of the design decisions of COSA is that you really have like everything inside the same container image or binary. So yeah. So
you keep track of where I am.
it's kind of it does a lot of magic for yourself. So.
Yeah, and I want to look at the magic when it's happening.
Yep. Yeah, so you need to exit then. Yeah, so that's the. Yeah, you have to exit yeah. Yeah. Checking the test name.
Haven't set up for the complete test name.
It's a good feature request.
At least feature suggestion.
You can open the tickets.
61,003 there, and then you reduce the 64,002. Try that one. Okay. Let's see what happens. I may misremember things, but worth a try.
While I get through customer service, you can give it a try. Technical support. Have you tried rebooting? Did you plug and unplug? What's your user?
1002.
No, the lab user number. Number two?
Sorry.
Yeah, okay. Yes. Yeah, the next step which you will fix yeah, you kind of investigate. This is taking you from the step like you are developing your Fedora CoreOS. There is an actual problem. What do I do to find out what's going on? The fact that the test spec doesn't match what you do. You have the same also? No. Which user? 4, 5. You see the conversation anyway in Slack with the Steve. Raining. Because it's in /var/temp, which I think is shared by, it might not be user specific. I don't know. Should have said this is the first time we do this workshop. So you're guinea pigs. Thank you for your contribution. The set enforce 0.
Yeah. When you close the account, okay. Okay. Yeah, and the problem is that the var TMP area is used by everyone, so it's not using mine only things in there. So we map var TMP var to var TMP, and then it's the same path inside.
And like if you see it's owned by user 19 now, like all the files are owned by lab user 19.
19, yes.
Which is the user we used to test the workshop. So it works.
Yeah, it is from 1419, so that's when you tested it.
Yeah, it worked before, but now that we do the
I see that.
Yeah, when we do the multi-user, it's just bear with us 1 minute.
If you remove that, I start my command before he starts his.
Yeah, it's like a serial. You have to take a ticket. we have one of the team members looking at it. So. No. How is your battery now? 10%. Cheers.
What would I need on my own machine in order to use these tools directly?
Just like, you know, the first bash command, like the COSA, you can just do that and pull the container and you should yeah. The lab machine is really just convenience.
Yeah. So I was curious if I go back to it afterwards.
Yeah, you should do, everything should work.
It's not provisioned in a special one.
No. That's the good, that's like, yeah, that was one of the philosophy behind this tool, is that it works the same everywhere. Just, Okay, so we should have a fix. It's like iterative development. So if you refresh the tutorial, the markdown file, and pretty much in the first bash function where you define the COSA alias, just remove the /var, like the volume for. Yeah, you can just recopy the alias and you should have it. We copy paste that one. Cool. You have 1 minute left. We'll leave the lab machine on anyway, like for like today, so you can continue. The actual tutorial?
Yeah, so I can find it again. I mean.
Yeah. So I'll put it in the session, in the scheduled session. And if you ever have like any questions or anything related to this, there's the Fedora CoreOS channel on Matrix or IRC, and you can just pop up and ask, like, I'm trying to run this, it doesn't work, help, and be happy to help. What time is the bus thing? Do you know? It's like 1/2 past. The bus, yeah, for like, the, 1/2 past, yeah. Yeah. Say again? Ah, yeah. Yeah. Thanks, Anka. Thanks, everyone.